Today we are here to discuss the topic of compass surveying in the topic Geomatics engineering. Now, in compass surveying, we have seen that there is lots of questions asked in the GATE examination. So this is very important topic for the GATE examination. And we'll be trying to study here three aspects, mainly the true bearing, the magnetic bearing, the declination, and then we'll be looking forward to the local attraction as well. So let's start with compass surveying, and we'll look at the topic compass surveying in depth today. Let's see. Firstly, we all know that we have a constellation. Now, constellation contains of 7 stars, and now we also know that we have a pole star, which is the brightest star in the universe. Now, if the pole star comes directly in straight line with the constellation, any 2 stars of the constellation, and then if we project that line on the Earth's surface, this becomes our true north. Now, if we project this line on the bottom surface of the Earth, we will get our true south. Okay? And this line is nothing but called as the true meridian. Okay, now let's see how do we calculate the true bearing of any line in our Earth. Let's suppose this is our true north and this is our true south. Now, if a line is in the first quadrant, then this angle theta in clockwise direction from the true north connecting the line AB is nothing but called as the true bearing. So here theta will be our true bearing. This is also called as the whole circle bearing of the line AB. Now, if we connect a line for suppose AC from the true north, this angle will be giving us theta 2 will be our true bearing for the line AC. Similarly, if a line is in third quadrant, this angle in clockwise direction from the true north to the line AD will be giving us the true bearing of the line. Now, this is all about the true bearing, true meridian, true north and true south. Now let's see what is magnetic bearing. Now, magnetic bearing. Magnetic bearing is nothing but the angle measured from the magnetic north. Now what is magnetic north? Now in our Earth we have magnetic formations everywhere in the Earth's surface, mantle, crust, everywhere there is magnetic formations. So those magnetic formations have a resultant direction. So if we keep our compass on the center, it will align itself to the magnetic north. Now let's see what is happening. Now for example, this is our true north, and for example the magnetic resultant has been here. This is the direction of the magnetic north. So for example, if I keep my compass over here, it will align itself to this direction. So this is nothing but our magnetic north. Now, if I want to measure any bearing of any line, let's see, for example, this is again the line AB. Now, we knew that this angle is theta 1 and this is nothing but the true bearing of the line AB. Now, what is the magnetic bearing? Magnetic bearing is nothing but the angle measured from the magnetic north to the line AB. Now, this angle alpha 1 will be nothing but our magnetic bearing of the line AB. And this angle phi between magnetic north and true north is called as declination. Here, this phi is in clockwise direction. So this is called as positive / eastern declination. Now, if this angle psi and if this point is magnetic north, so this is nothing but psi, this is nothing but in anti-clockwise direction, so this psi will be nothing but negative / western declination. So, if I want to calculate the magnetic bearing, I can say that that is alpha 1 and nothing but alpha 1 is equal to theta 1 minus phi. This minus is coming because I want to subtract this angle when I am measuring this line. Now here I will recommend the students not to learn any formula. They have to just project the true north, the magnetic north, calculate the declination, and easily from the diagram they can visualize the magnetic as well as the true bearing. No need to remember any formulas in this topic. Now let's move forward to the topic local attraction. Now I told you that magnetic north is nothing but the line which is having a resultant in that direction, and that is composing of the Earth's own magnetic declination, that is Earth's own magnitude, Earth's own magnetic field. Now we know that there can be any further formations of magnetic materials, for example magnetic fence, for example my belt, any small particle, any small magnetic formation, that is nothing but the external factor. Now internal factor was Earth's own magnetic field, and this is nothing but the external factor. So external factor will deviate the magnetic north little bit on the eastern side or on the western side. We'll see how is it happening. Now for example, this is our magnetic north. Now due to some external factors, the magnetic north is now changed to the new magnetic north. Okay, so this angle, that is nothing but Q, is nothing but our local attraction. This is also called as positive / eastern local attraction. Now if this angle is P, so here P will be nothing but our negative / western local attraction. So now the magnetic bearing which we will be measuring will be from this angle. So from here, if this angle is measured as, for example, K angle. So if this is our line AB and the angle measured by us is K, and we call it the magnetic meridian, but that is wrong or measured magnetic meridian. So here the wrong, or we can say the measured magnetic bearing of line AB will be K. But we know that the magnetic meridian should be measured from where? The magnetic, that is the true magnetic north. So now we'll call the true magnetic bearing of line AB, that will be nothing but equal to angle K plus Q. So now we can easily understand that the true magnetic bearing of line AB will be this angle plus this angle, because we have to reach the magnetic north. As the magnetic bearing of any line is the angle measured from the true magnetic north to the line that is to be considered. Now Here, due to magnetic local attraction, we have some kind